She is a graduate teaching assistant in the math
She's
department.
really ours, is what we're saying.
We're paying for her. That's what it is.
Hi everyone, my name is Becky Peters. I am a math education major, and so this project was one that I did for a course, for an education course. The project focused on learning about an instructional strategy that we could use in our particular content area that would work for dealing with students who have disabilities that will be in our future classrooms. The area that I chose to talk about is an instructional strategy for students with intellectual disabilities, and it's called Concrete Representational Abstract, or CRA for short. The Concrete Representational Abstract Instructional Strategy, it has 3 components to it. It's 3 stages. The students move across the 3 stages to support problem solving, so you can't do the 3rd stage until you've mastered development at the 1st and 2nd before it, because each stage does build previously on the other. The CRA instructional strategy helps to promote student learning and retention. It also helps to address conceptual knowledge and understanding, which is a really strong emphasis that NCTM, the National Council of Teacher of Mathematics, focus on. They are really pushing for teachers to get their students to learn have conceptual understanding of the content they're working with. This strategy also helps to support understanding the underlying concepts of why things work before learning rules. So understand why multiplication tables work by dealing with area models and figuring it out hands-on before just learning 4 times 6 is 24. So as I mentioned before, it has 3 stages to it. The first stage is the concrete phase, otherwise known as the doing stage. It's where students will work with concrete manipulatives in front of them and actually get their hands on the manipulatives to help them figure out how to solve the problem for whatever topic they're working on. The second stage is the representational stage. This is the seeing stage. This is where students move on from using the concrete manipulatives in front of them to putting those away and still using that idea, but using that idea by drawing pictures and images on paper. So you still have the idea of the area or whatever it is that you're working with, but you're doing it visually with diagrams instead of having to have all of the objects right in front of you. The third stage is the abstract reasoning phase, or the symbolic stage. So for the math world, this is where students are able to use abstract reasoning using only mathematical notation and symbols in order to solve the problems in front of them. So in order to implement this strategy in the classroom, the first thing that you have to do is the teacher has to describe and model problems to their students and do demonstrations of what they want their students to do at the concrete stage with the concrete manipulatives. After they've described and modeled it for them, then they have to provide a lot of practice opportunities for the students to be able to work with the manipulatives themselves and figure out what is going on behind the scenes of the problem and why things work the way they do. Once they develop mastery at the concrete stage, then you want to go on to the seeing stage, where we work on, okay, here's the problem that we solved with the concrete manipulatives. Now let's, instead of playing with them with our hands, let's draw those on paper and figure out with the drawings on paper, how can we draw them out to represent the problem that we're looking at. So the teacher describes and models by drawing figures themselves for their students to understand, and then they also provide a lot of practice opportunities for the students to gain mastery at this stage. Once they move on from the representational stage, you can move on to the abstract stage. Again, the teacher is going to be the lead for this. They're going to demonstrate and model how this works at the abstract phase and model those examples for students, and then provide a lot of practice opportunities at the abstract stage for students to gain mastery at the abstract phase. So once students have mastered all 3 stages, it's important for teachers to periodically check up and check to see if the students still have retained their mastery of that particular content knowledge by providing pop-up opportunities to practice those skills at all 3 developmental stages, the concrete, the representational, and the abstract as well. Part of the project was then to use the strategy that we picked and did research on, and then demonstrate how we would use it in our classroom. So as I said before, I am a math ed major, so I chose for this CRA method to demonstrate it by doing the Pythagorean theorem. Now I know a lot of people here, or just people in general, generally don't like math, but this is something that you guys are probably familiar with, even though you probably have blocked math memories for most of your life. The Pythagorean theorem is a squared plus b squared equals c squared, and the theorem states that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other 2 sides. So since I can't hook up an Elmo and show the demonstration here in front of you as well, I actually have a pre-recorded video that I'm going to show you to demonstrate the 3 stages of me modeling the CRA method by teaching the Pythagorean theorem.
So to demonstrate using the CRA method, I decided to try and do it with the Pythagorean theorem. And the Pythagorean theorem says that the square of the hypotenuse is equal to the sum of the squares of the other 2 sides. So for the first stage of the CRA, which is for concrete understanding, I would have a Pythagorean theorem manipulative, and I have a right triangle. This is a 3 by 3 square for this leg, and this is a 4 by 4 square for this leg. And using the Pythagorean theorem, these 2 added together should make up the square of the hypotenuse. So I have 16 squares here and 9 squares here, which 16 plus 9 gives me 25. And the best part about this is you can move the squares down and rearrange them to fill in the hypotenuse square. And this gives the students with learning disabilities an opportunity to understand the concept using concrete materials that they can actually get their hands on and understand the concept using these concrete objects. For the second stage, which is the representational stage, you want to use what the students learned using the concrete manipulatives and get them to represent that using pictures and diagrams. So I have graphing paper, and I drew another right triangle, which is 5 by 12, and has a hypotenuse of 13. So I use graphing paper because it has lots of squares that you can use. So I drew a square of the one leg, which is 5 by 5, which gives me 25 squares. And then I drew a square of the other side, which is 12 by 12, which gives me 144 squares in here. If you add up 144 plus 25, you end up with 169. And I drew a separate square that I could use to examine the hypotenuse. With the way that it's set up on graph paper, if you drew a square, you would have partial squares, so it'd be harder to tell the area. But if you draw a separate square, then you can have it line up, and you can see that the hypotenuse is the square of the sum of the other 2 squares. So the Pythagorean theorem still is working like it should, and this gives students a way to see this visually and using the representation stage. So moving from concrete with the hands-on manipulatives to seeing it on paper, drawing with diagrams and pictures. After the representational phase, once they have mastered that, they can move on to the abstract phase, which is using just mathematical notations and symbols. So say that I didn't know that the hypotenuse of this right triangle was 13. I could use the Pythagorean theorem to solve for the hypotenuse, the missing link. So the Pythagorean theorem states that a squared plus b squared equals c squared. I could plug in my 5 squared, which I know, and my 12 squared that I know, and that's equal to the square of the hypotenuse. So again, I get 25 plus 144 is equal to c squared. Adding them together, I get 169 is equal to c squared. Take the square root of both sides to get c by itself, and I'm left with c is equal to 13, which is the hypotenuse of this 5, 12, 13 triangle, which is what we saw when we did the representational phase as well. So this allows them to use the concrete stage to build their knowledge, and then use it at the representational stage, and then to be able to move on to the abstract stage where you don't have to draw all of the pictures and diagrams, and you understand the underlying concepts of why things work. I hope that my demonstration helps you guys
That was the end of the video and the presentation, and these were the references I used to do my research on the instructional strategy. Are there any questions you have for me?
First, thank you for very well done.